All right, let's make a racing game in arcade. That's right, it's a switch and bait. I'm not making a racing game. The speaker, Mr. Verdes, is a version that doesn't exist, at least not in this universe. This is the only time Sonny Valdez will acknowledge that none of the following bio is real. Mr. Valdez is a luchador in a universe that is like our own. While luchadors are known for physical wrestling, Mr. Valdez came from a world where they perform as programmers. Having accidentally transported here by a strange Python program, Mr. Valdez hopes to one day return to my reality. In the meantime, he has spent time sharing secrets from the universe. By complete coincidence, that knowledge is applicable in this universe as well. All right, hello everyone, I'm Mr. Valdez and let's make a racing game. Today, I'm going to show you how to make a pseudo 3D superscalar game. A long time ago, there are computers don't have the power to even properly scale an image. As you can see here, the 1981 game Turbo, you can see that it's fate scaling. They're just changing the sprite for something that's bigger, but it doesn't really change. A superscalar is a game style that usually run on a specialized machine. Some superscalar arcades even have three 6800s processors running games such as Power Drift. For this talk, I had a choice of two games to copy, Space Harrier or Outrun. Because of hubris, I've decided to tackle the harder one, a car running on the road over a free-moving spaceship. I got some knowledge from the internet, so all of this isn't actually new. It's not from me. I got it from somewhere else. Some computation should be pre-computed instead of computed manually every frame. And there are some deep maths on 3D projection that unfortunately I have to simplify super. I'm sorry for those who are looking for a very good math explanation. Cecily, all the maths here would be, trust me, bro. And yes, it hurts me. I can't explain it. I wouldn't be able to explain the math. The code structure is built for presentation and not for best practices. And this is just an excuse to do a lot of coupling and using globals. Oh, I can see a lot of sad face. A lot of people are more sadder about the best practices over the maths. Anyway, let's start. First, we're going to get arcade running with basic data structures. So this is our data structure. We have vertices, and we have segments. This would be the segments of the road. We have a camera. I'll explain that in a bit. All of this will be explained. Because I need to explain the road data structure first. This is our data structure. We have vertices, and this on the right is the road, and the road will be broken up into different segments. And that segment would be the road, and you'll see this later on this data structure. We're going to render starting from the bottom upward. So starting with P1 to P2, then P10, we move to the next segment, and so on and so on. So this is it. We have a camera, and here's the road. And we're going to create some 100 segments. We're going to alternate between gray and dark blue. And we're going to render the data structure. To render the data structure, we're going to change all of this data. Just remember, this is 100 data points, 100 segments. And we're going to put it on screen. Our rendering is just simple. Take all of the segments. This is P1, this is P2. Get the projection, so from data structure into 2D space, and then draw the segment. Our drawing is just simple. we're just gonna draw a rectangle. Let's run it. That's it. It's just a blank thing. We're doing that, we're doing it this way, just to see that it's working, that something is being rendered. And it's just a blank gray space. Now, I'm going to teach how to project from 2D data space into 3D. Here is the math. I know it's going to be simplified. We have a camera, and the camera would have a position. We have a data. Here, the Utah teapot is our data. This is written as a data structure. And we have something called the new plane. This would represent our monitor. This is the math. This triangle over here, that triangle over there, that's how you get the render. That's how we project. I'm skipping the maths. So, let's render the road structure in 3D. So this is the math that we skip, a lot of math. And yes, this is just copy-paste. I tried to do it live coding, typing, and there's no way I could do all of this. We need a function to get each segment on where the camera is. And this is the code to render in 3D. We're going to look at each segment. We're going to send the data. Remember, we built the data from bottom up. And then we're just going to send it to the same function to draw. What will happen is the word data, the data inside the data structure, would be projected into 3D on the camera space. And finally, we need to make sure that we are actually rendering the 3D. Okay, may the demo gods be nice to me. The demo gods are not nice to me. Okay, so this is the screen, and we don't see the 3D yet because I see the mistake. Okay, so I skip a step. Sorry about this. The joys of live coding. I forgot to mention, we only used gray earlier. So this is our 2D. This is our 2D. And to show you that it's actually the data structure, for every other segment, we're going to change it from light to dark. And it looks like this. So this is our segment. This is the bottom one is the first segment, second segment, third segment, and so on. Now let's render it in 3D using the math that I skipped. And from 2D, we're going to do it into 3D. Still boring because, hey, what did I do? I just did some math to move the data into the z-axis. Sounds boring. Well then, we're going to add the music later. That's how we made it exciting. You know what? Let's do it now. That way I could also test my sounds.
Ships, motorcycles.
Yeah, it works.
With circus
The music
life.
works. Now, it's kind of boring. It's just a straight road. What we need is the road sides, lane markings, and side grass. So to do this, here we go. So this is the code for that. We're going to add colors, different colors for the road, for the grass, and on the side. I'm a professional, I can copy paste. Reset and load. And create. By the way, this code would be on my GitHub, free for everybody to check out after the talk. All right, so what we did is we added color to the segments. And what? It was working earlier. Ah, oh no. I'm crying. It happens. What did I do? It's because I did not even copy. Wouldn't that be why? Okay, let's calm down. Need to calm down. I know my code. Calm down. Sorry about this. because I accidentally took that out. Yes, live coding. Now, this is still a little bit boring. I need to show you that this is actually 3D. So, I'm going to add a camera. We're going to let the camera move in. So what we're going to do is have the camera follow the player. And hey, we need to trade a player class. And have arcade show the player. Okay, on update has to be taken out, and on draw has to be taken out. All right. Okay, so. Oh, right, I need to unzip. Oh, this one is part of the joke. Now, we have our car. It's moving ahead. I already added the vehicle, and we're moving the vehicle. There is also a visual bug. So I did some shortcuts already. Because of time, I lost some time there. But there were some visual bugs that would appear in which this would oscillate because it's trying to draw the polygon at the back of the camera. And it looks really funky. And I want to save everybody time. We're going to skip that and go to the next part, which is adding the curves. Now, in a racing game, we're going to curve to the left and to the right. I need to explain something called interpolation. Here I am showing 3 kinds of interpolation. Linear, is in, and is in out. They would arrive at the same location at the same time. However, the timing in which they get there, or rather, how fast they move between different points, is done using the formula. So let's go to the curves. So here, we're going to one thing I forgot to do is show everybody that this is infinite. So I did that by changing the color. It's too fast. You'll see that later. I'm more worried about my time. All right. Here's the render 3D. Oh man, so we're running out of time. I'm gonna do a lot of shortcuts. There's a demo.py that I already created, and it's here that's already completed. We have a curve. We have curve here. This is the formula for the ease in and ease out. And what we are trying to do here is add some curves. It's going to move. There's a curve to the left. For 20 sections, it's going to slowly that's there. Hold for 40, and then end for 1 frame. So I'm gonna cheat because of time. This is the final output. So one of the things, there's a hill. And one of the things that you need to see is if I hit the corner, it's going to stop because of physics. How much time do I have? Less than 10 minutes. All right. So this is the quick explanation of the curves. So each data structure, each segment has a value for moving left, for entering, holding, and then exiting to the right. So I already added the, one of the things that I need to talk about is the parallax. If you look at the back, this is going to move separately on each one. If you look on the GitHub, you will be able to see how I do this in order. All right. Now, how much minutes more? All right, so 5 minutes. Well then. I cheated a lot. Nice to have. Adding side trees, adding other cars, and adding a winning condition. Now, I'm going to, there's a game chart over here that's going to do some cheating to show you that I also know how to make a good game in which I'm winning. And see your body in the moonlight, even if I can't sell all the pictures. In the mind, there's a flashing in my eyes. Don't you see my commission? The nation has done running again. Can't you see now? Illusions right into your mind. Deja vu, I've been on this place before, higher on the streets, and I know it's time to go. Calling you, and the search is a mystery. Standing on my feet is so hard to beat, I can say that was a bad, a bad coding. But hey, I tried.